Perfect. Hello, welcome to the talk, Creating Elegant Builds at Scale with Gradle. My name is Dockter. I'm the founder of Gradle and the CEO of Gradleware, the company behind Gradle. And when we talk about scalability and builds, actually there are quite a few dimensions that are relevant for scale. It's performance, it's how can you hide the complexity to the normal developers, it's dependency management, and quite a few more. So I will talk about some of those scalability dimensions when it comes to build and continuous integration, continuous delivery pipelines. So before I go into that, I just want to talk a little bit about what I think is the state of our industry when it comes to building and shipping software. So as part, one thing we do with Gradleware, we do a lot of consulting around continuous delivery, build, continuous integration. So we are involved with many enterprise software stacks, including some of the largest software stacks on the planet. So we have quite a bit of insight into what is going on, and the reality for most organizations that have larger software stacks at least is that the feedback cycles are way too long, the degree of automation is low, the quality of service of the build and delivery pipeline is not very good. Often there are problems with the quality of the shipped software, and the time to market of features is way too long. And that is where one of our major focus is, right, and always has been. It's the medium to large software stacks and the problems they have. So, and we think that our industry is at the beginning of a revolution similar to what the car industry has seen in the 90s with lean production. And we want to be, or we consider ourselves that we want to drive that, right? So it's always interesting how people can get accustomed to pain, and we see a lot of pain in our domain. And I mean, you might have a positive perspective on that. You could see, well, I can see with one eye, and I still can breathe a little bit, right? So, but that won't help you much if you have that pain with your build and with your CI, because the pain is going to increase. So one thing is that the software code bases, they're growing and growing. So we see typical growth rates for some of the large software stacks we're involved with between 20 and 100% per year. So with such growth rates, even with 20%, right, you have your code base is twice as big in 4 years. So when you have, let's say, build times of 5 hours, right, and you have distributed teams, in 4 years you will have build times of 10 hours, and then your system will collapse, for example. And that is what most of the organizations are facing as software is eating the world, basically. And the growth rates also usually means you have more and more people in your team. So, which means the inefficiencies you have, they will become more and more costly to you. The other thing that is happening is that your software stack is increasingly more complex. So 7 years ago, a company could have said, we are a Java shop, right? Those times are over. You now at least Java, iOS, and Android, and most likely also JavaScript and some native code. So the heterogeneity of the code bases is a reality that is increasing more and more. And traditionally, build systems have been designed around a certain software platform, and that is not working anymore. So there's a lot of complexity you get from that side. The other changes you see is the architectural change towards a microservice design, which makes definitely continuous delivery more challenging. And that's another dimension of complexity. And the only way to solve that is to have a true multi-platform build system, right? That's our opinion. And it's interesting to look at some of the organizations who are very successful in shipping their software and very efficient. One of them is LinkedIn, one of the large Gradle users. They have they have 1,000 people built, right? 4,000 submodules they're doing with Gradle, and they invested a lot into improving their delivery capability. So if you look at LinkedIn in 2011, it took them 30 days to ship a new version of their software. Do you think this is good or this is bad compared to other organizations of that scale? So who thinks this is already pretty decent? Right? Yeah. So I think it was way above even current industry average, considering a team at that time of 500-600 developers shipping one stack, right? So, but if you look at that number, releasing every 30 days means once you have a feature completed, it sits 15 days in the shelf. You have an inventory term of 15 days. What they have achieved in 2013, and they're still improving it, is they're now able to do 2 releases per day, right? And they now have 1,000 developers. So that means they have increased their inventory term by reduced it by a factor of 30. This is revolutionary. This is a massive, massive improvement. And think now that you're competing with LinkedIn, right? As another organization, you would now have a serious competitive disadvantage if you're not able to do the same. And that's another reason why companies have to invest. At the moment, quite a few organizations can get by with a very inefficient process because their competitors are not doing better. But this is going to change, right? Okay, so another thing I want to quickly talk about is the momentum of the Gradle technology. So when you introduce a technology in such a critical infrastructure space as build, like changing a build for a team of 50, 100,000 people, you're not just interested in the features of the technology, people are usually very conservative in terms of what is the future of that technology, how safe is it to bet on that technology, right? So people want to be sure that a new build technology is around in 10 or 15 years. This is often the lifespan of the technologies we are replacing, and people want to be sure that the problems they have been successfully solved with the same technology somewhere else. So the threshold of entry in this market is very high, right? So there has been an armada of new build tools, but in terms of having traction in the enterprises of all the new build tool, there's only one, that is Gradle. Until the middle of the year, we had just in this year 2 million downloads, right? So if you look at Google Trends, that is what Google Trends is saying about Gradle. So you see very, very, very strong dynamic. And even if you go compare it with other well-known technologies like Cloudera, you see there's a lot of substance in there. So even if you compare it with Hadoop, we're now at 30% of the Hadoop value for Google Trends. So many books are out there for Gradle. There was an interesting survey by the JRebel folks asking what technologies are developers most interested in, Java developers. They asked 2,000 Java developers, and from all the technologies in technology space, Gradle was the technology where developers said we want to learn more about. So I guess that's why you're here. So let's get started. So one very important aspect of dealing with scale is how easy is it to describe and specify the reality of your software stack, right? And Gradle has introduced some very powerful concepts, components and variants. Some of that is brand new, right? It's just in master and it's still incubating, but and I want to talk about that. So one thing, talking about being a multi-platform build system, those are platforms that are either already true first-class citizen in a Gradle land, or we are working on making them first-class citizens, right? So Gradle is not a Java build system where you somehow squeeze in some CC++. They're completely on equal footing with the same support. That is our approach, and I think that is crucial for modern enterprise software stacks. So if you look at this is the workflow to ship even a simple Android application. So Java, in terms of continuous delivery, is one of the simpler domains. It still has a lot of complexity once you have a larger stack, but some domains, Android and even more so CC++, are much more challenging. So there's a lot of complexity in the Android world, and I just want to show you how we model this this world so that you can efficiently deal with this complexity. Okay. So